Hello everyone, now we are here to do the introduction of exercise 5.2 in which we are going to study the complex plane or argand plane. As we know, a complex number z is x plus iota y, and we have always an order pair with respect to this. Means x plus iota y is the complex number, so we can write it as an order pair x comma y, where x will be real part of the number and the y will be imaginary part of a complex number. And we know how to represent the order pair in a plane where two x's are there, one is x and one is y. That plane is coordinate plane or Cartesian plane, but there is some difference. The difference is now we have to represent a complex number where x's will show the real part of complex number and the y-axis will show the imaginary part of a complex number. Other process is the same. We have to represent x comma y order pair. Some x is there, then y, and we will get that point. Now this point is not a simple point, it is a complex number representation. So the plane where x-axis represents real part and y-axis represent imaginary part is called complex plane or argand plane. Yes. The next is, we know that the modulus of z will be root x square plus y square, real part square plus imaginary part square, which we have already studied. This modulus of z you can see in the plane, you can see in this trace, will be the, if this is origin and this is the point x comma y, so this distance will be root x square plus y square. We know that. How to find this? By the distance formula. And this will be the distance which will be the modulus of z. Means the distance of this point, this order pair from the origin is to be represented by the modulus of a complex number. Now if we take another complex number, z equals to x minus iota y. This was z equals to x plus iota y, x comma y. It is the representation of this. Now if we take z equals to x minus iota y, which you know that it is the conjugate of this given complex number, order pair will be x comma minus y and the representation of this will be x positive, y negative, like this, and distance of this from the origin will be same, root x square plus y square, which is modulus of given complex number, which is the conjugate of this complex number. One thing we also get by this, that the modulus of a complex number and the modulus of a conjugate of that complex number is always same. Now we'll discuss the polar representation of a complex number. Suppose we have a complex number x plus iota y. We know that order pair is x comma y, and इसको कैसे represent करते हैं plane में? From x, y, and we get the point x comma y. But is this the only way to reach at this point? No. Let's see कैसे. If we go from the origin at this distance, but the direction is also important कि कैसे direction में जाना है. Anti-clockwise direction from x-axis, from positive x-axis. ये वाली डिस्टेंस कवर करके एक्स एक्सिस से एंटी क्लॉकवाइज डायरेक्शन में जाएं तो हम इस पॉइंट पे पहुंच जाएंगे. दिस डिस्टेंस हमें पता है, दिस इज द मॉड्यूलस ऑफ z. दिस इज टू बी रिप्रेजेंटेड एज r. मॉड्यूलस इज टू बी रिप्रेजेंटेड एज r एंड द डायरेक्शन जो एक्स एक्सिस से पॉजिटिव है उसे हम रिप्रेजेंट करेंगे थीटा से. सो जो ये पॉइंट है x, y, इसको नाउ वी विल चेंज टू r, थीटा. वी गेट द न्यू कोऑर्डिनेट और पॉइंट के ये न्यू कोऑर्डिनेट इज कॉल्ड पोलर कोऑर्डिनेट्स. पॉइंट के कोऑर्डिनेट को हमने चेंज कर लिया पोलर कोऑर्डिनेट्स में. अब हमारा काम है कॉम्प्लेक्स नंबर को चेंज करना पोलर फॉर्म में. कैसे? अगर हम x एंड y को रिमूव करके r और थीटा की फॉर्म में चेंज कर दे तो डायरेक्टली वी विल हैव द पोलर फॉर्म बिकॉज दीज आर द पोलर कोऑर्डिनेट्स. हाउ टू चेंज दिस? लेट्स सी. See this x, this is r, this is theta. We know that the horizontal components are cos theta. Vertical components will be r sin theta. Now put x value r cos theta plus iota, y's value is r sin theta. Take r common, we'll have cos theta plus iota sin theta. X, y has been changed in r theta. Complex number has been changed in the form of r and theta. So this is the polar form of given complex number. We will have some question on this. करेंगे हम. But first of all see there, r is modulus of z. So what is theta? Theta is direction. This theta is called argument of z. Theta is called argument of z. और जब भी हम whenever we talk about the argument of z, we will talk about principal argument. हम इस थीटा की वैल्यू को एज अ प्रिंसिपल आर्ग्यूमेंट ही कंसीडर करना है एंड दैट प्रिंसिपल आर्ग्यूमेंट विल लाई बिटवीन -π to π. This will be the values of theta only. -π to π, principal argument. This is represented by argument z. Two things you have to just remember कि अगर हमारे पास r and theta है तो हम किसी भी कॉम्प्लेक्स नंबर को can change in the polar form. r is the modulus, easy to find. Now we will learn how to find theta, how to find argument which is theta. Just 2 points you have to remember. Number 1, you have to find alpha, any alpha. That alpha will be tan inverse modulus of imaginary part upon a real part. Means tan inverse modulus y upon x. That's it. First of all you have to find the alpha. The second part, theta, we have to find now. Theta will be dependent on alpha's value with the considering quadrants. We have 4 quadrants: first, second, third and fourth. Theta you have to find by the quadrant. Means the complex number किस quadrant में lie कर रहा है ये थीटा उस पर डिपेंड करेगा. अल्फा यू हैव टू फाइंड एंड थीटा की वैल्यू हमें अल्फा से मिलेगी. ये डिपेंड करते हुए कि क्वाड्रेंट कौन सा है कॉम्प्लेक्स नंबर का. इफ वी हैव अ कॉम्प्लेक्स नंबर इन फर्स्ट क्वाड्रेंट मीन्स x, y है, -x, y है, -x, -y है और x, -y है. अगर कॉम्प्लेक्स नंबर फर्स्ट क्वाड्रेंट में लाई करता है तो थीटा की वैल्यू विल बी इक्वल्स टू अल्फा की वैल्यू. क्लियर? अगर वो फोर्थ क्वाड्रेंट में लाई करता है देन थीटा's वैल्यू विल बी माइनस अल्फा. राइट? if the complex number lies in second quadrant, the theta will be pi minus alpha. And if it is in third quadrant, theta will be minus pi minus alpha. That's it. First of all, you have to find the alpha, which is tan inverse y upon x with mode. फिर थीटा की बारी आई, क्वाड्रेंट से पता लगेगा. फर्स्ट क्वाड्रेंट थीटा विल बी अल्फा, फोर्थ क्वाड्रेंट थीटा विल बी माइनस अल्फा, सेकेंड इज थीटा इक्वल्स टू पाई माइनस अल्फा, and if it is third, theta will be minus pi minus alpha. That's easy to find. We'll do some question. This is the question. We have to change in the polar form. We know that we just need two things to change a complex number in polar form, which is r and theta. If you have r and theta, you will easily change it, and the polar form is r cos theta plus iota sin theta. First of all, we will find r, which is modulus of z, x square plus y square, 1 plus 3, which is 4, and 4's root is 2. Now the turn is to find theta. For that we will have alpha first. Alpha is tan inverse y upon x. Tan inverse root 3 upon 1. Tan inverse root 3 at which angle? 60. Now the theta's value will depend on the quadrant in which complex number lies. Let's see. Both are positive. First quadrant, and we have studied in first quadrant theta equals to alpha. So easy. Which will be 60. Now put the values. R2 cos 60 plus iota sin 60. This is the ultimate polar form of this complex number. Or 60 you can also write pi by 3 as. Next example we have this. We have to change it in polar form. Polar form में change करने से पहले सिंपल बनाएं कॉम्प्लेक्स नंबर को, रियलाइजेशन करें डिनोमिनेटर का. 1 plus iota root 3 is in denominator, 1 minus iota root 3 से मल्टीप्लाई करते हैं. So we can make it simple. In denominator it will be a square minus b square, and in numerator it will be minus 16 plus iota 16 root 3. 1 minus iota square is minus, minus minus plus, root 3 square is 3. Four, 16, take it out, because हमें पता है ये कट हो रहा है. यहाँ से भी हमें मल्टीप्लाई करने की फिर जरूरत ही नहीं थी. We have taken 16 out. 4. Now the complex number will be minus 4 plus 4 root 3 iota. This is the complex number. Now we have to change it in polar form. We need two things, r and theta. First of all, we'll find r. R is modulus. Find it. Minus 4 square plus 4 root 3 square, which is 16 plus 16 into 3, 48. 48 and 16 is 64, and it will be 8. Now the turn to find theta. Theta के लिए we have to first find alpha. Alpha is tan inverse modulus imaginary upon real. Tan inverse imaginary 4 root 3, real minus 4, 4 to 4 cancel, modulus become positive, root 3, tan inverse root 3 is 60 or pi by 3. Now theta, consider the quadrant. In which quadrant it is? X minus y positive, second quadrant, and we have done it. In second quadrant, theta is pi minus alpha. So theta will be pi minus pi by 3, because alpha is pi by 3, it will be 2 pi by 3. This is the modulus, this is the theta, and the complex number will be changed in polar form by putting the r's and theta's value. R is 8 and theta is pi minus pi by 3, 2 pi by 3. That's it.